Okay, hello everyone. Great to see you. It's great to be back together in New York. This is probably my 14th, 12th event since COVID ended, or at least COVID got better, let's put it that way. But first one in New York, and it's just great. It's just great to be back. I'm catching up with everybody, and I know you're going to spend the next 2 days sort of catching up with people and so forth. By the way, we have 5 empty seats right here, folks. So people in the back, if you don't feel embarrassed, come on right up in the front. We got five seats right there. My name is Bruce Momjian. I work for Enterprise DB. Been with them for 16 years now. And very excited to be talking to you today about the challenges to Postgres. Now, if you're looking for these slides, feel free to go to this URL, which is right here. And you will find 58 presentations there, 650 blog entries, and probably over 100 videos. So feel free to take a look at that material. Why is this an important thing to talk about, right? It sounds like kind of a downer. Postgres challenges, like, it doesn't sound like good news. Well, as one of the core team members, my responsibility is to look for threats. What threats could potentially affect Postgres? What things could slow us down? What things could derail the great success that we've had for the past 26 years, I guess? And that is part of my job, and of course part of the core team's job. So I'd like to focus on effectively 4 things. The first is to talk about the current status of where Postgres is in the environment in terms of success and sort of where we are as a community. Then I'd like to talk about 3 primary areas of challenge. One is project challenges. That is, where could the project be challenged as an open source project? Secondly, competitive challenges. Obviously, there are other databases out there. How do they relate to Postgres? Could they be challengers down the road? And finally, and this might be the surprising part, we're going to talk about technical challenges. Believe it or not, that's the least of my concerns as sort of one of the project leaders, because effectively the other 2 are areas that we typically don't look at a lot. The third one we're kind of aware of. We have a very vibrant community in that area, a lot of people looking at technical challenges of Postgres every day. So I'm going to cover it, but again, that is sort of, to me, a solved problem. We've been around long enough as a community that I think our strength is solving these type of problems. We may not solve them as quickly as other people would like, but I have pretty good confidence. But I'd like to explain them to you so you kind of know where some of those pitfalls are and the things we're looking at going forward. So current status of Postgres is actually very good. We've had 35 plus years of continuous development. That goes back to the time at Berkeley in 1986. We've had 26 plus years of major annual releases. And again, we have a very strong community. Many of the community members are here. People who like to write the release notes and package things up and test things and do commit fest management and release management. We have an unbelievably competent team, really to the point where I don't even worry about what's going on because I know it's in great hands. So, and that's not true of every project. Sometimes these things aren't handled really smoothly. Fortunately, with Postgres, we have a very dedicated group. 180 features roughly every year. I believe Postgres 15 coming out. Somebody help me next week, week after, anybody? What's 2 or 3 days? Very close, very close. Roughly 172 features. So again, we're in that 170, 190 ballpark pretty much all the time. And of course, quarterly minor releases, very high quality security fixes and so forth. We are BSD licensed, which means the source code's available. You'll see a number of companies here who have forked Postgres and created versions of Postgres that are customized. That's great. It's great to see them using the code. Great to see them taking stock Postgres, which is focused on generic workloads, and sort of moving it to specialized workloads. Very exciting. And of course, they're also members of the community. They also continue to support us and give us energy. We have a very diversified leadership across multiple companies, across multiple geographic areas, and so forth. And again, that's a healthy thing. I'm going to show you some examples where that diversity has not been there and has led to unfortunate outcomes. I love this slide. It kind of just breaks down for Postgres 13 all the companies involved. That big sort of orange one, or it should be orange, but it's red, is my employer EDB. But again, it's not a majority. It's just one of many. When I usually give this slide at other locations, I will highlight companies in Japan who are on this list, companies in Europe who are on this list, companies in Latin America, and so forth. We've got some of the big ones like Fujitsu and NTT, which have been with us since the early 2000s. And we have some of the newer ones who are just getting involved. Again, everyone kind of treats each other the same, and it's a very welcoming place for companies to get involved. Of course, you know, as a leader, I have to say, okay, what if one of these companies goes away? Because occasionally they do. And fortunately, over time, the EDB contributors are normally absorbed into other companies. So again, looking at risks and so forth, I'm not too concerned there. But again, I just love how many slices there are of this pie. That tells me that we have diversity and we have resiliency. I love this slide too. This is talking about, because Postgres is multi-company and multi-region, we have people improving Postgres in every direction every year. So we have usability improvements, we have improvements in performance, in new workloads, in enterprise capabilities, all at the same time. Really nothing not to love about that slide. Most loved database relational database in 2020. That's all I wanted to kind of give you the good news. Now I want to walk into some of the concerns. I've been around open source since 1991, so I've seen some of the pitfalls that some of the projects have been into. Some of them are ugly. I'll try and explain it as best I can. First off, leadership disruption. Many of you may not know, but the GNU Image Processing Program, or GIMP, actually was abandoned by its leadership in the early 2000s. The leadership didn't want to continue with it. They stopped, and for about 6 months it kind of languished. And then eventually another team picked it up. Similar to the way Postgres languished in the 95, early 96 period until the group that currently works with it kind of took it up. I'm not sure how many of you are aware of this sort of CentOS saga, but in this case, because of lack of diversity in the leadership of the CentOS team, Red Hat effectively took it over and sort of moved it in a direction that the majority community members didn't want. And that's why we have Rocky Linux right now. So that's like a Shakespearean story almost. I couldn't make it up, but it's pretty nasty. Feel free to look up the details if you're curious. But again, a good example of lack of diversity and leadership, where a company controls where the project goes, and then things don't go the way all the user base typically wants. Poor reputation. We are a database, so reputation is a key aspect of who we are, right? And there's a lot of mistakes you can make. There's one database, it's called Firebird. How many people have heard of it? It was originally Interbase out of Borland. Borland released the source code in the late 1990s, and there was a team just similar to Postgres who picked it up and was releasing versions of Interbase called Firebird at that point. Unfortunately, there was a hard-coded password in the source code that Borland released, and they had been releasing for perhaps 18 months this code, not realizing there was a password, hard-coded password in there. And their reputation suffered because of that, because you're sort of like, oh, what else aren't they seeing? I mean, you can understand how sensitive people are, particularly to a database. So reputation is really key. I'm really happy that we have a crackerjack team of people around the world. If something weird happens, I usually hear about it, or the leadership team hears about it. And often I hear about it after it's already been resolved. So somebody has already resolved whatever issue we have. and leadership hears about it, says, oh, this was dealt with, or whatever. But we're always having an eye on that, because that reputation is absolutely critical to our success. Security flaws, buggy releases, instability, poor performance, data corruption, they could all kill your project, specifically a database project. Makes sense. Patent attacks, I'm not sure how many of you know the ugly landscape that is patents. I'm not going to go into the ugliness of all of these issues, except to say that, at least in the United States, it's the patent attack landscape is almost unpredictable to the point where it could debilitate software projects. There have been some attacks against open source projects, particularly by Microsoft in the early 2000s. They support us very strongly now, but the past is the past. It was an issue with patents on their file system years ago. Rambus, that's like another Shakespearean saga of RAM and patents and standardization. Also, sort of patent trolls. Now, there is some good news here. The Open Invention Network is designed to allow sharing of patents among open source projects. Oracle, Microsoft, IBM are all part of that, so that takes a little bit of the sting away of possibility. There's something called unified patents, which is a newer process to try and open patents. And finally, somebody made me aware of something that Cloudflare is doing to try and create a process to invalidate ridiculous patents, or patents that just should not have been validated. So very interesting stuff. Just something to keep an eye on. Identities. Obviously, the identity of Postgres and the project is something we have to protect. The domain name, the website, even the trademark. We do have an ongoing litigation related to protecting the trademark. Hopefully, that will be resolved soon. I'm pretty confident about that. But again, it is something that, as a project, you have to keep an eye on, because it is part of how people identify you, and therefore validate that the actual source code they're getting is from the same team. If you have problems with identity, you lose that ability. This is a weird one. I actually wrote this. This is not as big a problem as it was perhaps 2 years ago, but I want to highlight it because there was a lot of talk a couple years ago about, how many of you have heard this sort of problem? Is this a general? No, nobody's heard of it. OK, so I got one. So the basic issue, and you've seen it a lot more from proprietary databases, but the case is that a cloud provider could use your open source software so much that they eclipse your own open source project. So people associate the software with the cloud provider and no longer with the project itself. The project starves from resources. It's possible. I'm not saying it's going to happen. We have seen many of the cloud providers get more involved with Postgres now since I wrote these blog entries back in 2020. AWS, for example, has gotten much more involved in the past 18 months than they were previously. So I think there's a sense that cloud providers do understand that their involvement with those and their injection to make sure the projects become healthy is actually benefiting them. But it was not as clear a couple years ago. You still see things like Elasticsearch, Mongo sort of struggling with how to work with the cloud providers. Again, very interesting story. There's some URLs there at the bottom. OK. Let's change gears. Let's talk about not project challenges now, but competitive challenges. So we have a big database market. What competitive challenges could we have in that big database market? Well, there are other solutions. There are other database solutions out there. Some of them for streaming, some of them specifically for full text search, some of them for data warehouse and document and so forth. We could get to a point where some of these specialized databases effectively eclipse the value of a relational system. Now, I've been around long enough to have seen challenges to relational systems over the decades. XML databases, object databases, if that rings a bell to anyone. So there have been challenges, but what's really neat about relational, and particularly Postgres, is that we see a new workload, we see a new way of using a database, and we subsume the best parts into our database. You've seen that with JSON, you've seen that with full text search, you've seen that with GIS, you've seen that with some of the non-relational data types like range types that we support. I have some presentations about that, but the good news is that relational currently looks pretty strong, but again, you keep an eye on that. We have a lot of forks of Postgres. I mentioned that before. There's a great diagram talking about some of the forks we've had all the way back into the 90s. The important point here is that Postgres remains accessible. It remains flexible. It remains something that's always looking to see what new workloads, what new things should we be doing to meet the market demand. If you stop doing that, effectively another database as one of your forks could become the database everyone uses. The best example I have here is EGCS. Anybody remember EGCS? Yay, I got two, okay. EGCS was a fork of the GCC compiler because the GCC compiler was no longer improving the optimizations of the compiler at a sufficient speed. GCC had become stagnant. So EGCS basically creates a fork of GCC, had a whole bunch of optimizations. Within 2 years, most people are running EGCS now, no longer GCC. In fact, to the point where the GCC people have to decide to abandon their copy of the source code and move to the fork as the official GCC. So the GCC that you run now is effectively EGCS. Again, an example of a project not evolving to meet the needs of the market. You always want to be keeping that aware in front of your mind. Again, relational could decline. I don't think it's going to. In fact, we saw NoSQL kind of rise and sort of now level off to where it makes sense, which I think is a healthy thing. But it is something you have to keep an eye on. OK. Final section is technical challenges. This might be the challenge that you think of as a user of Postgres, which is great, which effectively means that the other things I talked about, you don't worry about because you figure they're handled and you figure they're never going to be a problem. And they may never be a problem, but you don't want to have a CentOS surprise, OK? Where we have to rename ourselves to something else and try and move everyone to a new website and try and get momentum in a new project. We're an EGCS case where a fork of Postgres becomes, and nobody knows what version of Postgres they should be running, and there's problems in the market. So the good news is that we worry about the previous. These are the ones that you probably are thinking of in terms of where Postgres is going for workload usage. First one, really hard to nail down. We've kind of come upon the term of write amplification. I kind of like the term. Came from, I think, Uber. But basically, they were using Postgres in a way with a very high write workload and a very unusual use case. And because of the way Postgres is designed, it has a tendency to write more than some relational systems, and that was insufficient. Now, this was many years ago. I don't hear about this problem so much. We've made pretty dramatic changes in how Postgres handles high write volumes. Particularly even recently, we have a way of merging duplicate B-tree entries, which typically happens for high update workloads. That was in Postgres 14 or 13. I'd love for somebody to do another benchmark and tell me how we're doing in this area. Do we need to do something radical, right? Z-heap was a radical approach, did not really come to fruition. But again, we're continuing to look at this kind of workload. Secondly, cluster file encryption, or what we call TDE. I've been working on this for 5 years. We're getting a little closer, but it's hard to get buy-in on the community for this feature. I'm hopeful for something for Postgres 16. We don't know. I do have a slide deck down here at the bottom, a URL that has a lot of detail, and then there's some slides and so forth. But again, I think this is something we should focus on. Horizontal scaling, or what we call sharding. We've been working on this also for 5 years. by improving foreign data wrappers, parallelism, partitioning. This is pretty powerful, and I would argue that you can already do some of this in Postgres 14. I haven't seen any benchmarks yet, so I don't know. Again, it's an area I'd like us to see more work on. This one's kind of weird. You're like, what? This one, because Postgres code base goes back to 1986, we continue to modernize it, but we also must modernize the tool chain. So the libraries we use, the build environment we use, the testing environment that we use, even the language to some extent, right? Like what if C is already not as used as it was years ago? What if that declines? Okay. Our build system, some of it's written in Perl. What happens there? What happens when the XML library that we rely on isn't available anymore, right? What happens if architectural changes happen? I don't know. But again, it's something we keep an eye on. And finally, changes to technology. So these would be cases where the technology of the data of the actual operating system has changed so much that you effectively really have to redesign everything. Now, the good news is we haven't had too much of a problem there. Probably one of the big changes we came across a couple years ago was the SSDs, because obviously SSDs have better random access performance. And the way we fixed that was to effectively add a random page cost per table space in case you mix SSDs and magnetic in the same cluster. Obviously, cloud, virtual machines, containers became big. We had to change? Like nothing. We look like geniuses that we work so well in this environment, whereas all the other relational databases seem to struggle. But I'd love to say that we knew 20 years ago that this was going to happen, but we didn't. It's basically part of the design of Postgres to be minimal, to rely on the operating system as much as possible, and to be basically a good general purpose database without becoming too tied to some complex things that may not exist or may not function well in some of these virtualized environments. So the good news is that we're kind of in good shape, I would say. Project-wise, obviously, we have a lot of momentum. Our momentum continues to grow. Even in the past 2 years, I'd say the momentum has become more extreme, more accelerated. Project, I think we're healthy. If we're not, please let me know. But everything that I've seen shows that we're healthy. Competitive-wise, I think we're in good shape. We continue to bring in new workloads. People seem to now standardize on Postgres. They're trying to leave a lot of the proprietary and NoSQL databases because they realize the value that we bring. And then obviously, technologically, we are making slow but steady progress to address some of the technology challenges that we have. So again, I've only had 20 minutes to speak to you. I'm sorry I wasn't able to go into more detail with some of these. If you have any questions, certainly come and talk to me or any of the other Postgres leadership. We'd be happy to help you. And thank you for your time.